Hey, Algebra 2 friends, here we are. We are looking at section 12.4, and we're going to be talking about dividing rational expressions. So last time we talked about multiplying rational expressions, and I talked about when you're multiplying rational expressions, you just mush the numerator and denominator together and you have a canceling party. That's what we're going to do here, except we remember when we're dividing fractions, right? Let's say a over b is a fraction, then I have c over d as another fraction. I'm dividing them. We know that that means we would take a over b and change the division to multiplication and take the reciprocal of the fraction following the division sign, right? We know that these two are equal, so we're going to apply that knowledge here. So I have 5x squared over 7 divided by 10x cubed over 21. That means that this is the same as, notice I'm keeping the first fraction exactly the same, changing my division to multiplication, and yes, I'm taking the reciprocal of the fraction following the division sign. Now I'm going to smush, right? Now I'm going to just mash everything together. Some people like to cross cancel before, which is totally cool. I support you. Let's go ahead and do our thing. So x squared, well, I don't know, 5. Let's do with the 5. 5 breaks down, that's now 2, 7, boom, that's 3, that's 1. X squared and x cubed, that goes away, and I'm left with just an x down here. Check it out. Looks like almost everything is gone. We have a 3 up here. Even if this 3 were canceled out somehow, we know that the numerator would be, when we cancel, we know that we're actually creating like ones here. I hope that makes sense. So I could have put a 1 here and a 1 here. But anyway, we've got the 3. 3 times 1 times 1 is 3. 1 times 2 times x is 2x. And my final answer is 3 over 2x. Let's look at this next example. It's going to be kind of similar. We're going to do the smush factor again. So I'm going to first change my division problem into a multiplication problem, change division sign to multiplication, and then take the reciprocal of the fraction following the division sign. Reciprocal, we remember, means to switch the numerator and denominator. Now, I'm going to smush, but look, I'm smushing with parentheses. Putting parentheses around everything to show that I'm multiplying all of these values together, n plus 3. And what I'll do here is factor this. I'm not going to FOIL. I'm never going to FOIL unless well, I shouldn't say never, but that's not going to be my go-to thing to FOIL. I'm talking and doing wrong things. What I did do is I factored out the 2 here. When factoring out the 2, now I have several things being multiplied at the top and being multiplied at the bottom. Opposite of multiplication is division, so when I cancel, I divide. So that's what happened there. I divided the top and bottom, and now I'm able to get n plus 4 over n plus 3. That quantity is being multiplied by the number 2. So this is my fraction that I'm left with. We have this guy, which is very similar. 5a plus 10 over a plus 5. We're going to change our division sign to multiplication. But wait a second. Look at this fraction, a plus 2. It's not a fraction, right? Well, we could always throw a 1 in the denominator and make it a fraction. So with that, now that we've changed our division sign to multiplication, we're going to take the reciprocal of the fraction that follows the division sign, and that will be 1 over a plus 2. Smush factor, put everything together, factor out if you can. A plus 2. 5 times a plus 2 is the same as 5a plus 10. The 1 is negligible, so I'm not going to write that down. Then I have a plus 5 here in the denominator and a plus 2 here. The a plus 2's cancels away, and I have 5 over a plus 5. If we look at this next example, very similar idea. Sometimes I like to factor before I smush them all together, but let me go ahead and just write out exactly what I'm going to do. I'm going to take my first fraction, leave it alone, change my division sign to multiplication, and take the reciprocal of the fraction coming after the division sign. When I've done that, now I'm going to smush everything together, but I want to smush everything together as it is factored. M plus 2. Who's tired of me saying the phrase smush? I am. I will say something else. So M, 2, 1, plus, plus. I think that's proper factorization. M plus 1 times m plus 2. That's from this part of the numerator, and then times m plus 1. So I've put all of those together. These guys cancel out. I'm left with m plus 1 quantity squared over 4. That's my final answer. And our final problem for a change of pace is a dimensional analysis problem. In November 1996, NASA launched the March Global Surveyor. It took 309 days for the orbiter to travel 466 million miles from Earth to Mars. What was the speed of the spacecraft in miles per hour? Round to the nearest hundredth. So let's go ahead and think about it. We've got miles per day, so we've got 466 million miles that we're dealing with, and those miles were covered in a period of 309 days. However, we want our answer in the form of miles per hour. So the miles we don't mind having, but it's the hours we want to change. We want to change the days to hours. So what we do is, you remember we talked about this before, we talked about changing your units by making a kind of a gourmet one, a special one for our situation. And the special one that we're going to use will involve days and hours. So if I had 1 day, how many hours would that be? How many hours is 1 day? Everybody knows it's not 12, so I shouldn't write that down. Everybody knows it's 24. And so 1 day is equal to 24 hours. I can make a unit term, meaning I can make the number 1 by either putting 24 hours on top of 1 day, right? Or I could write it as 1 day over 24 hours. What happens here when I do this is that I create in a sense, a conversion factor that will change my units to what I want. So here I want miles to remain, so I'm not changing that, but I want days to go and for the days to be replaced with hours. Here's the one I'm going to use because hours is on the bottom. So 1 day, the days will cancel, over 24 hours. And so now I'm already set up to get my answer in miles per hour. This large number, 466 million, divided by the product of 309 and 24 times 24 is going to give us our answer. And with a little bit of help from Desmos, here's my answer, 62,837. All right, so there's our answer, 62,837.11 miles per hour. And on that note, I'm going to let you all go. Hopefully this made pretty okay sense, and we will talk soon. Take care, guys. Bye-bye.